Okay,
Okay.
oh, let me just change the view to speaker view. Okay, so welcome everyone. I'm Caroline Champney. I'm the publisher of the new journal ePrime here at Elsevier. Excited to welcome you to the first webinar in the series. So I'm here with Karanesh, who's an early career editorial board researcher, and he's going to be organising the questions at the end. So ePrime was launched around this time last year, and it's a new open access, fast turnaround journal in electrical engineering, electronics and energy. And it's been launched to help increase the impact of your research across disciplines. So today, our first webinar speaker will present on the detrimental effects of water on electronic devices. And she's going to be discussing how water in various forms can affect the performance and reliability of modern electronics in unique ways. So before we start the presentation, I'm going to introduce Ilknur Beylokoglu. Sorry, I have problems.
Okay. Thank you.
So Ilknur is a senior chief researcher with the department and department manager of a specialty engineering and integrated logistics with TÜBİTAK Advanced Technologies Research Institute in Ankara in Turkey. She holds BS and MS degrees in chemical engineering from Middle East Technical University, and she was a research fellow for 2.5 years at CAS, which is at the University of Maryland, USA. Ilknur was also chief researcher and group leader of reliability and safety with TÜBİTAK Space Technologies Research Institute, also in Turkey, in Ankara, and she was the owner of consulting company Saturn, working in reliability engineering. Ilknur's research interests include reliability analysis and life predictions in high technology electronics, product development for satellite and avionics systems. Ilknur is the author of 2 book chapters, and she's published several articles. So I'd just like to introduce you and welcome you to go ahead, Ilknur. Thank you for joining us today.
Thank you very much, Caroline, for the introducing of me. Hello, everyone. Actually, today I will talk about, as Caroline mentioned, the effects of water in its different forms to the electronics. And I planned my talk not in deep technical aspects. It's going to be much more giving some idea about the effects of water forms on electronics, and our paper will give much more detailed aspects of technical issues. Actually, I'm trying to go my next slide. Why I can't go? Sorry. Okay, it's here. Now, our planet is a water planet, actually. Earth is composed of 70% of water. And of course, water is very vital for our life. It's also very important in some critical biological cells. And also it is very important for some industrial applications. Actually, we are also using electronic devices in our daily life on our water planet. During these last years, electronics is much more in their daily life. We are using it in pools, beaches, to take the camera photograph of the people during taking photo. We are using it very close to the water contamination risk. And also, when we talk about the effect of water, for example, this picture is from Bodrum, which is a very famous holiday town in Turkey. The exposure of water of these cars, electronics, will cause them in a danger because of the muddy water. And maybe different failure mechanisms can happen in the electronics of the car. And what can be these failures, these mechanisms caused by water? One of the most famous one is corrosion. It is very known failure. Actually, it is a very widely seen phenomena, and it is caused by the water in its different forms. Corrosion is a reaction of a material with its environment. Actually, it is in general, corrosion is causing some failure modes which are irreversible. When there is a mechanism caused by moisture, a corrosion mechanism, is an electrochemical process. Actually, it is can be a galvanic corrosion or it can be a creep corrosion. As you can see here, there is a creep corrosion, and this one is an example of galvanic corrosion. Actually, galvanic corrosion could be because of the coupling between, for example, aluminum and gold with the presence of water film on the surface. The water film works as an electrolyte, and the electrochemically active aluminum becomes the anode, and it corrodes. Actually, at the end, metal oxides are deposited on the gold. In the creep corrosion, it is also a galvanic corrosion, and it can form when a silver or gold finished boards like this with the level of sulfur gas and with the moisture. And at the silver and copper contact site, sulfur can dissolve into the moisture to form an acid electrolyte solution and promote the corrosion. Indeed, copper is much more reactive than silver. It serves as the anode and produces copper sulfides, which are subsequently precipitated and grow around the silver-copper contact sites, as shown here. Actually, in today's electronic components, most of them have a different type of finishing materials because of after RoHS directive, restriction of hazardous substances directive, there are different alloys can be used in the finishing of these materials. This can be a silver alloy, tin alloy, and sometimes we can face maybe different type of alloys on the same board. So these risks, of course, can cause the corrosion phenomena. There is another corrosion example on the hearing aid battery spring contacts. Actually, there is it is again a galvanic corrosion observed in the battery contact springs of hearing aid. Because in the contact springs, it is made of nickel electroplating with gold finish, and these pores are found on the gold surface, which appear to be formed by corrosion resulting from salt dissolved in the water. Due to the pores, the galvanic corrosion occurred between the underlying nickel layer and the gold surface, and the resulting metal oxide had high brittleness and caused cracking or delamination of the gold surface, which made the nickel layer more exposed, as shown here. And there is another corrosion type of failure, which is conductive anodic filament formation. It is but an electrochemical migration derived failure mode. As it is seen here, this conducted filament is inside of the printed circuit board layers. It is not visible by naked eye, actually. And it is between the spacing between printed circuit boards plated through holes. These are plated through holes, which components can be immersed in it, or maybe they are just via holes. This transportation path of metal ions can form at the fiber resin. This is actually insulation layer, and in this fiber resin interface may be caused by the manufacturing quality of printed circuit board, or maybe the material properties, maybe because of the thermal cycling, and some other factors may affect to have this conductive filament. And the water molecules and copper ions produced at this anode side, and then they move to the cathode side along the moisturized transport path, forming a copper filament. It is really difficult to this copper filament to predict the effect of some microorganisms. Also can cause this type of results in humid environment. So some very weak acids produced during the metabolism of these microorganisms. And they can cause the corrosion. Because of this, in some of the high technology and high reliability projects, they ask for the fungus resistance test, which to able to see the effect of the microorganisms effect. And there is another example of electrochemical migration and dendrite dendrite formation on a capacitor. This is again electrolytic corrosion driven by electrical energy when there is a water film connects to biased conductors. And there is electrochemical migration is an electrolytic corrosion derived phenomena and consists of conductive dendrites, these called dendrites, and it happens on the insulating surface. Moisture provides a conductive pathway. Electrical current flows due to the electric field between two biased metals. And metal ions form on the anode surface, move along with the moisture, and at the end subsequently it deposits on the cathode as a form of dendrite as seen here. And the effect of moisture and water for the material properties is also very important, especially some polymeric materials. It causes the degradation of polymeric materials. Of course, we have lots of different materials on electronic device. We have both some polymeric materials, some metal structures, some ceramic materials. Because these polymeric materials absorb moisture and change its physical properties. It can change the volume, it can change the elastic modulus. Since the water molecules interposed between the materials, molecules may disturb the original interactions. These type of degradations can be observed in polymers, especially because they are hydrophilic materials. Hydrophilic materials are attracted to water molecules. So their hydrophilic parts can have some change between the polymer and, for example, adhesives applied to the interface of components. Adhesives degraded by moisture and induce cracks in devices like here. Also these devices, especially during the reflow process, they face the high temperatures, very high temperatures. These cracks can happen. Under humid environments, some residual chemicals in adhesives can react with water molecules to form acids, which degrade interfacial adhesion. This type of delamination-induced cracks occurs at different different places, and it causes some stresses. During this moisture absorption of these plastic materials, they can cause some popcorning mechanisms during the reflow process. Because of this high temperature, these absorbed moisture vaporize and expands with a high stress, and they can cause cracking of the material. So because of this, during the component selection, the moisture sensitivity level is really important, because if it is needed, especially a long-term storage for critical applications, usually it is needed. You need to service the product maybe more than 20 years. Then, of course, you need to store some of the components or assemblies. So their moisture sensitivity levels are very important. Depending on moisture sensitivity level and the criticality of the product, maybe you need to use some special nitrogen storage, under nitrogen storage. And also the processing precautions need to be taken, like to have these components advanced before the process, need to get them from the storage. I will give some more detailed explanations related with these issues. These failure mechanisms, which type of failure mechanisms in electronics, as we summarize here, they can be some, we mentioned corrosion, it is very widely faced one, and also leakage current can have on transistors, for example. This is leakage current is an electric current that flows through an unwanted conductive path. Actually, it is also due to moisture. It is found in transistor devices, and as a mechanism known as the surface charge spreading can occur under a humid environment. Related with these moisture-caused failure mechanisms has been investigated by Sandia Laboratories, and they reported that 20% of electronic failures are caused by water-induced corrosion. These failures, as tabulated here, can be intermittent failures, maybe short-term failures resulting from the water film formation, or they can be long-term failures due to the water-induced degradation of the parts. Usually these intermittent short-term failures are unpredictable, and given that they depend on transient climatic conditions or unexpected exposure to water. Most of these degradations are irreversible, and they require the replacement of parts that we have several times faced this type of failures in our professional life. There are several examples in the literatures. For example, one of the example of moisture damage is in 2008 crash of US Air Force aircraft. It was determined that moisture on the sensors caused the jet to receive false data recording, and the loss of this aircraft were estimated as $1.4 billion, but thanks God the pilots did not die. So then we talk about lots of failure mechanisms and caused by water, water and moisture. And we mentioned that water is our planet's mostly composed material. But then what is the water? What is the moisture? Why it can affect the materials so much? Actually, water is composed of 2 hydrogen atoms and an oxygen atom. And the atomic nuclei form an isosceles triangle with an hydrogen-oxygen-hydrogen angle of approximately 104.5 degrees. And its resulting dipole moment is 2.95, which makes water an extremely effective solvent. It can solve everything, actually. And it is when especially substances dissolve in or in bond with water, the properties of water can be dramatically affected. For example, the conductivity of water is very different than the conductivity of the seawater, because seawater has 3.5% of salt, and its conductivity can be increased 10 to the 6 times more. When we have a problem with seawater, for example, with our cell phone, it's really, really hard to, if we drop our phone to a seawater, it is really hard to recover it later on. And there is a moisture we are talking about. Moisture is either a gas phase water dispersed in air, or it's a water vapor or condensed water absorbed on its surface or absorbed within a solid. And also we talk about humidity very much. It is the measure of the amount of water vapor in gaseous state, typically air. Usually in our electronic products, requirements definition from our customer, they ask about this humidity and temperature parameters very seriously. They ask to actually, I'm getting some sound from background. Sorry. Okay.
Maria, could you mute yourself, please? I think we have a bit of sound coming through from you. Thank you.
Okay. Okay, and then when we have the contracts in high technology products, they usually ask to have the parameters for humidity and temperature. They expect the resistance of our product to able to work under these type of conditions. Actually, we define absolute humidity as the total mass of water vapor present per unit volume of air, and the relative humidity as the ratio of the partial pressure of water vapor to its saturated or equilibrium vapor pressure, which refers to the moisture capacity in the air. So relative humidity depends on temperature and pressure. For a fixed absolute humidity, when the ambient temperature falls, the saturated vapor pressure decreases and the relative humidity increases. And then after we define the different type of waters, we can come to the how this water enters the electronic devices. Actually, there are various ways. Actually, liquid water enters the interior of electronics from its different openings. And direct contact with liquid water occurs when electronics are splashed by water, rained on, or submerged. Sorry, I didn't want to go to the next slide. Okay. Also, water vapor can diffuse into the enclosure through the openings or from the permeable materials. And also there can be condensation, of course. Even some motor workers can be trapped in electronics during the manufacturing process, because in manufacturing process there is some cleaning operations after the soldering. And for example, cars, including electrical vehicles, can expose to rain and snow. And especially some Navy products, some ships may contact seawater, which is much more dangerous. It can be an aerosols in the atmosphere. Because of this, some Navy electronics requirements are really, really hard to complete. And liquid water enters from everywhere, actually. And if there is a small opening, even it can enter. And moisture in the air also enters to electronics from different mechanisms, like difference of temperature, pressure, or relative humidity. And diffusion-induced moisture ingress occurs mainly through the openings, but also through permeable materials. And also advection is a passive transport which can made by bulk airflow. When there is an airflow through openings on electronics, moisture in the air can flow through it. So water can find a way to enter to our electronic devices, believe me. And condensation. Condensation is a change in the state of the water vapor into the liquid water and occurs when the relative humidity reaches 200%. The relative humidity of 100% can be achieved as the moisture in the air increases or the temperature decreases to a saturation point, which we call it dew point. And condensation also occurs at the solid surfaces whose temperature is below the dew point. And when these surfaces actually in products, in electronic enclosures or some electronic parts, they can cause they can have the condensation during the operation actually. In addition to condensation issue, there is a relation of because of the rapid decompression, which can occur especially in aircrafts because of the sudden loss in cabin. We can see some accumulation of water inside of the electronic device during this sudden rapid decompression, which is really dangerous. And how can we protect them, our devices? Is there any really protection methods actually? We are using enclosure. Actually, these can be casing materials, but they have some openings for some purposes, for example, headset jack, or some speaker microphone gaskets, buttons and camera. And these openings can be enclosed by adhesives, rubber or silicone gaskets, and mesh membranes. So we need to protect these openings. And casing materials have some openings for moisture entrance. But in general, materials whose atoms are densely packed, like metal, glass, and ceramic, they exhibit lower permeability than polymeric materials. But of course, they are heavy, depending on the application. Platforms, we need to decide which type of enclosures need to be selected. And of course, water ingress by such openings may be deteriorated by orienting the openings downwards for equipment installed outside, or minimizing the size of the openings and utilizing hydrophobic materials. Besides this, as the product ages, the openings can become enlarged due to wear and physical shocks. And openings covered with hydrophobic, which these are naturally repelling water, they causing droplets to form. And these can be used to regulate pressure in non-hermetically sealed packages without allowing liquid water to enter. And rubber gaskets and adhesives are used to seal the openings on product housings. These can be degraded by some environmental loads like salty moisture, temperature fluctuations, solar radiation. So even during the usage, these cracks and other defects may form and will contribute to moisture ingress more by time. And these enclosures, when we compare the enclosures, we can see the humidity buildup in polycarbonate, like here. Polycarbonate enclosures occurs faster than in aluminum enclosures because of moisture permeation through the polycarbonate material. You can see that there is aluminum ones can have less humidity buildup. So the enclosure selection is also critical for humidity and moisture degradation in the future. Another method is mostly used, the coatings. We try to protect our electronics by using some special coatings like potting or conformal coating. In potting, all the assemblies are completely immersed in a gel or solid compounds, which is mostly used especially for vibration environment application. And also conformal coatings are widely used to protect the electronic device, which is just only on the surface of the electronics. These can be some epoxy resins, some urethanes and silicone gels. Epoxy potting usually provides better adhesion to metals compared to urethane and silicone potting because epoxy resin mostly consists of various functional groups like ether, ester, amide, and amine. They can chelate metal atoms on the surface. However, epoxy materials are really hygroscopic. They attracting and holding water. So because of their nature, they cause some other various failure modes with moisture. We are using something to protect, but it can cause another failures, which we need, of course, a trade-off. Everything is trade-off. And when we talk about urethane, it is it actually has a similar adhesive force with epoxy, but it can be used in applications require flexibility, but its disadvantage is its low resistance against heat. When there is a high temperature above 90 degrees, its mechanical properties can be lost. And when we are talking about coatings, you can see here the moisture absorption of printed ball grid arrays, non-coated ones, and urethane coated ones here. And this is the non-coated ones. And this one is the perylene coated ones. The effectiveness of urethane and perylene for protecting a plastic ball grid array package is seems much better. It is observed only perylene could slightly slow down the moisture ingress. There is no evidence shown that conformal coatings could prevent moisture-induced failures. But of course, we need to decide, do we need to make conformal coating or not? Although conformal coating is not completely water protecting, but it is still used because of its insulation benefit by allowing reduction in conductor spacing, protection against chemical and corrosive attack, and by providing mechanical support and vibration resistance. Of course, when you have the repairing issues with conformal coating, you get much more troubles to remove the conformal coating, and you need maybe extra job to repair the devices. And in addition to these coatings, we can use some desiccants, dehumidifiers, and also baking methods. These desiccants can be used to suppress the humidity inside of electronics. They have a special adsorption characteristics. And they can be in any form, like packets and sheets, like here, tapes, some compressed forms, and even they can be integrated into a polymer. Compressed form of desiccants are mostly common desiccants in electronic products because they can be designed with a specific shape to fit a specific space. There are different types of desiccants like silica gel, molecular sieves, calcium oxide, like calcium sulfate. And in addition to this, the storage environment of the electronic spares for the long-term project is a critical issue. Because all plastic integrated circuit packages have tendency to absorb moisture. During the surface mount assembly, this moisture can vaporize. Actually, we mentioned about this, and this can cause crack. We mentioned about the popcorn effect, and since these plastic packages absorb moisture, care must be taken to prevent them to exposure greater than 10% relative humidity actually. And also we are applying the baking process, especially for integrated circuits and printed circuit boards, which they absorb the moisture and humidity from the environment. So before the assembly process, if we apply a baking process, we can able to remove their moisture inside, which prevents moisture-induced delamination and popcorn failures. And of course, to verify and validate the operation capability of our electronic products under a humid environment, under water environment, there are several test methods. These can be some military, IPC, JEDEC, ISO, IEC, BS, DIN. In our study, actually, we summarize and discussed different test methods to evaluate the product's water production ability. And also there is a special standard for water ingress protection classification. It is IEC 6529. There are different methods, and some of these methods also comes with the requirements in our product bidding contract to validate the capability of our product to survive under these humid conditions. And also some of these standard test methods can be applied during the product development to able to understand how these failure mechanisms are occurring and how robust are products that can resist to these conditions with temperature and humidity environment. We can apply these for aircraft, automobiles, submarines, cell phone, electronics, and also some PCB assemblies. It can be for different stage of the electronics. It can be just for a component, for bare boards, for PCB assemblies, for connectors, for cables. These test methods can be modeled for different levels of the electronics. And these specific test method selection depends on the application field and of course to the cost and the schedule of the product developments of the contracts. As a conclusion, there are several failure modes and mechanisms related to the form of water in electronics, as we see. And as we mentioned, water film may connect conductors and result in leakage current, and material degradation can happen by absorbing water for especially plastic parts. And also it can cause swelling of hygroscopic polymers and cause degradation. And there can be galvanic and creep corrosion, and there can be electrochemical migration. And the moisture between biased metals causes metal ions to migrate. So there are several issues can happen. As electronic companies, manufacturers, and designers in product development, we should not underestimate these detrimental effects of water on our products. There can be some hermetic enclosures, coating and sealing methods controlling the environment, as we mentioned, like baking. But generally, except for hermetic sealing, moisture gets into everything. So we need to mitigate and to avoid the water hazards. Maybe in our daily life, when we are using our electronic products, for example, when we are using laptops or cell phones, we need to use carefully. For example, if we forget our laptop in car in very, very cold weather in a winter day in our car for all nights, we need to be careful that after we get our computer, maybe we can have when we get it into the room, maybe we can have a problem with it. So, but for advanced technology, the specific application usage of electronics design and test all needs concurrent engineering work with designers and reliability engineers, safety engineers, to decide on how to select the materials, components, and how to design the tests to validate the product performance to able to work in the field. Because lots of failure mechanisms can happen caused by water forms. For target reliability and for the target safety, availability, manufacturability, maintainability requirements, all we need to evaluate the standards for testing, and we need to collaborate with design teams and reliability safety teams to decide on the components and electronics materials, including all connectors, wirings like this, to able to protect the product from water. These are all that I can talk tonight. It's night in my location. Thank you very much. If you have any questions, I appreciate to get them.
Okay, thank you, Ilknur, for such a nice presentation. Now I would like to invite participants to ask questions. Anyone have a question?
Hello, this is
Hello.
Marco Schönig speaking.